Today we're covering lesson 1.2 on dot plots and stem and leaf diagrams. So a lot of times we like to use a dot plot when we have data entries and we want to compare those data entries. So in a dot plot, each data entry is plotted using a point above a horizontal line. And we see an example down here of dot plot of minutes late to work. So what we have here is a company or an organization tallied the people who came in late to work, and we see 1 point represents how many people were late in each category. What dot plots allow us to do is they allow us to analyze the shape of data, or I should say how data is distributed, which is also called its shape. It allows us to look at specific points and to see unusual data, which is sometimes called an outlier. So if we look here at this column that I've highlighted in green here, you see that you have 4 dots above the 15, which means that 4 people were 15 minutes late to work. If you look at a different column, you would see how many people were late to work for other minutes. If I was to ask where were the highest column, let's take a look. It looks like right here. So it was most popular to be 2 minutes late to work. So let's take a look at defining range and mode. But I still want to see this chart. I'm just going to go up a little bit. So when it says, what does this column represent? I answered that here. 4 people were 15 minutes late to work. The range is defined as the maximum minus the minimum. So I can see here's my maximum of 26 minutes late, and my minimum is 1 minute. So here's my minimum. So therefore my range for this data set would be 26 minus 1, which is 25. Next, let's define mode. The mode of a data set is defined as the most. So mode is the most, meaning what is that highest column? It would be 2. So most, let's make this cleaner. Let's say it's the most frequently occurring data point. That's a more formal definition there, but I'd always remember mode is most and range is max minus min. Next, let's talk about shape, how a data set is skewed. So here I have 3 examples of whenever I draw a line above my data, how it is skewed. So this first example on the left, we would say that this data set has data, its shape is skewed left. On the far right, we see a picture where in this one we would say the shape of this data set is skewed to the right. And here in the middle, you can see it doesn't look like it has a tail flowing off. We would say this has no skew. It kind of looks symmetrical. Sometimes we call that normally distributed with no shape. So we have three options here. You can have skewed to the right, skewed to the left, and symmetrical or no skew. Notice that the skew is referring to the tail. So if you're wanting to think like, well, how am I going to remember this? Think about, does your data set have a tail? Let's go look at our data set up here. If I draw a line kind of following the data, would you say that this late to work data set has skew? And if it has skew, would it be to the right or to the left? And I'm looking at this and saying, I think it has skew. It looks like it is skewed to the right because I see this tail right here. So this data set is skew right. So here in your notes where it says skewed distribution, you can say skewed right, skewed left, or no skew are your options. And our data set for late to work is skewed to the right. So let's take a look at a couple dot plots and answer some questions. So here we have a dot plot of survey data talking about the hours of sleep that some people got. So it says, what is the range of the data? Well, the range would be the maximum minus the minimum. And my maximum here is 11 hours of sleep, and my minimum is 3 hours of sleep. So the range would be 11 minus 3, which is 8 hours. Next, what is the mode of the data? Remember, mode is most and the most frequently occurring data point. So it looks like my mode, I can see it so easily with a dot plot because it's just the highest column. So my mode here is 6 hours of sleep using this example. All right, let's do one more. It says the following dot plot shows the daily high temperature of Katz, Colorado in April. Each dot represents a different day. So notice these are temperatures in degrees Celsius. So how many days had a temperature of at least, that's important, at least 16 degrees Celsius? So if I'm looking at least, I'm looking at 16, 17, 18, and 19. I want to make sure I include all of those. So it looks like there are 7 days, according to this dot plot. Next it says how many days had a temperature below at least 11. So below at least 11. So here is 11 and below. So if it says at least 11, below at least 11, I don't think I'm including that 11. So here I had 3 days of 11. Sorry, my pen stopped working. 3 days of 11 degrees Celsius. If I was going to calculate how many days had at least 11 degrees, I would be calculating from that green line to the right. And since it's asking for below at least 11, I'm only going to tally the ones that are to the left. So it looks like I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 days. So that is all I have for dot plots. That is all of the basic information for those. Next, I want to talk about a stem and leaf plot, or a stem and leaf diagram, sometimes they're called. So let's look at on the left, it says stem and leaf plots. Construct a stem and leaf plot for the number of text messages sent by members of the junior class of PG. So PG represents Porter-Gaud School, and these are high school students. So when I'm constructing a stem and leaf diagram, look over to the right. Here I have an example of one. What you have on the left-hand side are called your stems, and on the right you have your leaves. And then you have a legend or a key that tells you how to interpret this. So 4 bar 7 would be equal to 47. I don't have any units here, so I don't really know what these numbers represent. But if I was going to look at, oops, let me go back. I wanted highlighter. So if I have this right here, this would mean in my data set, I have 80 showing up 1, 2, 3, 4, 5, 6 times. So 80, let's put the data value of 80 happens 6 total times here in this data set. I can also count how many total data sets I have here by counting the leaves. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So I have 27 total data points here, or entries here. If I was going to ask, like, what is the mode of the data for this question? Well, I would need to know the one that happens most often. All these zeros stuck out to me here, so I know that I have 6 80s. I'm seeing a lot of 2s here. Down here I have 1, 2, 3, 4, so I have 4 entries of 92. I think that's the next highest number. So it appears that 80 is going to be my mode. The range, I could also calculate the range. My maximum is 95. I'm getting that right here. And my minimum is 47. So if I subtract these two numbers, 95 minus 47, I'll get my mode. And so I'm going to pull an 8. So I get 48 is my mode. Let's see, what else do we need to talk about when we're talking about how to read a stem and leaf plot? Something to notice that the stems are in order from least to greatest. They don't always have to be in order from least to greatest, but they do always need to be in order, one way or the other. My leaves, notice they are in order from least to greatest, and that is most common, that they're going to be in ascending order. Also notice that the leaves have only 1 digit. So when you're going to do a stem and leaf diagram, it's important that you think about what your stems are going to be, because you want your leaves to have only 1 digit. So let's look at these text messages again, because we introduced what this data set was earlier. And it's the number of text messages that are sent by members of the junior class at Porter Gouge School. So I need to decide, looking at this data, what I'm going to use for my stems and what I'm going to have as leaves. So it might help to go through and highlight the 1 digits. So if you highlight what are going to be your potential leaves, it leaves you with what your stems are going to be. So it looks like my minimum is 92, I believe. Right here, looks like that's my minimum of 92. And my maximum, let's see, who's sending a lot of text messages? Looks like 100 and, is there 160 somewhere? I see a 159. Oh, yep, there's 160. Looks like that's the maximum right there. Or no, is there one bigger? 163, oop, that's my maximum. Luckily they have the same stem. So there's my min and max. So now I know what my stems are gonna be. So, and I do need to write these, even if you didn't have a stem, if you have a stem that's empty, it's important you still write it. So we gotta go from 9 to 16. So I'll have 9, 10, 11, 12, 13, 14, 15, and 16 is my stems. Now what I want you guys to do is go through and organize this and take this information and find all of the stems. So first let's look at the 90s. So I have a 92, let's find other ones. I have a 98 here, and let's see, I have a 96. Looks like those are all my 90s. So I'm gonna put those stems in order, 2, 6, and 8. I'm going to cross those out so I don't have those anymore. Next, let's find all of the data points that are going to have a stem of 10. Here I have a 109. Here I have a 104, I have a 107 and a 108 here. And then I have another 107. And I also have a 105 right here. Okay, so I think that's all of them. So whenever I am lining this stuff up, I'm going to go smallest to greatest. So I'm going to have a 4, then a 5 as my next leaf. I'm going to cross these out as I go. Then I've got a 7 and another 7. And then I have an 8 and a 9. So what I want you guys to do now is I want you guys to fill in the rest of the stem and leaf plot given our data entries, and pause the video to do that, and then come back whenever you are done. So go ahead and pause the video now and finish your stem and leaf diagram. Welcome back. So go ahead and check your stem and leaf diagram with mine. If you need to pause the video, that's fine. What this does is this lets us see all of these data values nicely organized in ascending order. So here we can see that we have, if I'm just looking at maybe this row right here, you can see that 1, 2, 3, 4, 5, 6, 7, 8 total data points are in that range from in the 120s of text messages that were sent. I can see that 2 were in the range of 160s in that range of text messages that were sent. So in this question right here, it says, what is the range of text messages that were sent from this data set? So I can see my maximum, I'm going to highlight it here in red, is coming here. So that's going to be 163. Minus the minimum is coming from the smallest number, 92. So if I take 163 minus 92, I get 71 text messages. That's going to be my minimum number, or my range of text messages that were sent. The next question is, what is the median? We haven't really talked about the median, but I'm sure you've heard of a median before. The median is going to be the middle data entry. Whenever you line up all your data from smallest to largest or largest to smallest, the middle data entry is the median. So I can add all of these up and see how many total points I have. You can start from the ends and count to the middle. I think what I'm going to do is, I can see I have 45 data entries because this is a 9. If I'm looking here, this is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just checking. So 9 by 5 chart. So I can multiply those together and I'm getting 4 to 45 total data entries. So my middle number is going to be that 23rd number. If I take 45 divided by 2, I get 22.5. So I'm really looking at that 23rd. So I'm just going to count from 92 and I'm going to count those leaves till I get to 23. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So that's my 23rd. I should have 22 on the right side. So I'm going to check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So again, I'm just checking to make sure. So my median is 123 text messages. So now, this last piece of information, it says if you rotate a stem and leaf diagram 90 degrees counterclockwise, so if you're looking at this, if you turn your head counterclockwise or rotate this counterclockwise, you're turning your head the opposite way, you create a histogram. And so what's happening with the histogram is you would be putting these data values into like bins. So my first bin would be how many text messages are in the 90s. My next bin in the 100s. The next one in the 111s, 120s, 130s, 140s, 150s, and 160s. So if you take your head and you turn it to the right, or if you take your computer and you turn it counterclockwise, you will see you've just made your first histogram. And we're going to be discussing histograms later. The last thing I want to talk about is just the shape again. So you can see the shape if you kind of look at your data values and draw that line, and then again you turn it counterclockwise. It doesn't look like this has a lot of shape to me. If I were to, no, I would say this is kind of symmetrical. There's not an obvious tail going on here. So it looks like this has no skew. So don't stress about the histogram piece. Again, it gets its own lesson, but I thought it would interest you all to know that histograms really just come from stem and leaf plots. So that is the end for the lesson notes for 1.2 on dot plots and stem and leaf plots.